This is Girish of ECE department, working as an assistant professor in Bvcits Institute of Technology and Science, Battlepalam, Amalapuram. Now, this is the first lecture on digital communication techniques. So, in this digital communication, today we will see pulse digital modulation. These are the topics which are to be covered in this lecture, but here today we will see only the introduction part. First of all, introduction. What do you mean by communication? Communication is the process of conveying the message from one place to another place by using a communication channel. The electronic equipment which are used for communication purpose are called communication equipment. Different communication equipments when assembled together to form a communication system. The purpose of communication system is to transfer information bearing signal from source to user destination via communication channel. Basically, a communication system is of an analog or digital type. Here we can see the source and the destination. Here the information is considered as from one point which is transferred through channel. Here we use wireless, and again it is reached to destination or user. Next, in analog communication system, the information bearing signal is continuously varying in both amplitude and time, and it is used directly to modify some characters of sinusoidal carrier wave such as amplitude, frequency and phase. Okay. In digital communication, the information bearing signal is processed so that it can be presented by sequence of discrete messages, means it will be in terms of ones and zeros, which is a binary information. Next, how the growth of digital communication system is large, which is due to the following factors. The first factor is impact of computers as a tool for communication, means nowadays we are using mostly laptops and computers which contain huge amount of digital information. Next, the second one is which offers flexibility and compatibility, means the information can be made in a compatible way and flexible way, means here we use ones and zeros. By using encoding techniques and decoding techniques, we are converting one form of digital nature of binary bits to another form of digital binary bits, which is here if we use one type of encoding technique, we can, for the same information, we can use another type of encoding technique also. For same message, means the digital message, we can assign different types of techniques, which is the flexibility which we have in digital communication. The next one is improved reliability, means the signal is received faithfully. Next, availability of wideband channels. Here there are number of thousands of channels we can be utilized. Next, last one is increase in availability of integrated technology. Nowadays we are using all the systems and laptops with integrated equipment only, means the integrated circuits which are very cheaply available nowadays. Next, sources and signals. Sources of information generates message, example human voice, television, picture, atmospheric pressure and temperature. There are two types of information sources, analog information source and digital information source. Analog information sources. These are the examples of analog information sources, which are microphone actuated speech, whether it is related to television picture, next atmospheric pressure and temperature. These are available in physical form, means from this these are given as an input to them. So here the microphone can be used as a transducer, means which converts one form of energy to another form of energy. Here the analog information source is what means here we use analog signal, means our voice is the analog information source here. Okay, here the pressure or temperature are the analog information sources. Next, discrete information sources. In discrete information source, the output such as teletype, numerical output of a computer, letters, digits or special characters may be used. Next, the message obtained from information source is not in electrical in nature, so there is equipment needed to convert one form to another form. So transducer is used to convert it into a electrical waveform, which is called the message signal, which is analog. The waveform is referred to a baseband signal. The term baseband is used to designate the band of frequencies representing the message signal. First of all, what is analog signal? An analog signal is one in which both amplitude and the time vary continuously over their respective intervals. Here, the amplitude and the time will be continuously varying, means it is a continuous varying function. Next, discrete signal. What do you mean by discrete signal? Signal whose amplitude is continuous. Here we can see the amplitude is in the form of continuous in nature, but the time slots, means the amplitudes sampled values which are taken are in discrete in time. That's why the amplitude is continuous and discrete in time slots, which is called a discrete signal. Next, what do you mean by digital signal? Now, digital signal is a physical signal that is a representation of sequence of discrete values, means a quantified discrete time signal. Both amplitude and time are taken in discrete values. Later, we have to convert the analog signal to digital signal. So what is the equipment needed to convert the analog signal to digital signal? So here we require A to D converter in the short form. Now means analog to digital conversion. Analog signal can be converted into digital form by combining three basic operations. Okay. These are sampling, quantizing, and coding. Here, analog signal is used by passing through this A to D converter and the digital signal will be obtained. Okay, how it is? See, in sampling, only sample values of analog signal at uniformly spaced discrete instants of time are retained. Means here the analog signal which we send through sampled and hold circuit results in sampled values of that original analog signal. Here the sampling may be used in three types. One is ideal sampling, next natural sampling, and flat top sampling. So apart from ideal sampling, natural sampling and flat top sampling are mostly used in practical. Next, the sample values which are obtained for the signal are passed through quantizing technique. So here, what do you mean by quantization? In quantization, each sampled values are approximated by the nearest level in a finite set of discrete levels. Now, during encoding operation, the selected levels represented by a code word means group of bits that consists of prescribed number of code elements. Next, this is the classification of communication. Here, the communication is divided into analog and digital communication. Here, in the analog, there will be two types. First one is AM and angle. Again, the angle is of two types, FM and PM. We know that AM means amplitude modulation, FM is frequency modulation, PM means phase modulation. Next, later, the digital communication again divided into two. First one is baseband transmission, another one is band pass transmission. Here, the baseband transmission means here we use low frequency signals, whereas in band pass transmission, here we use high frequency signals. So, examples of baseband transmission are wire channels like cables, twisted pair cables, etc. Here, we can see in band pass transmission, we use wireless channels mainly, like wireless channels including coaxial cables, optical cables, and microwave guides. Later, here we use the modulation technique, which is a digital modulation technique. Here, the digital modulation means the signal which we are taking is in digital form, which is a message, which is a digital, and it is modulated with the high frequency analog carrier, mean without changing the properties of the message signal, we are changing the properties of the carrier like phase, frequency, and amplitude. Again, the modulation is divided into two types. They are binary and M-array schemes. In the binary, there will be 5 techniques. So, the 5 techniques are ASK, FSK, PSK, DPSK, DEPSK. Okay? ASK means amplitude shift keying, FSK means frequency shift keying, PSK means phase shift keying, DPSK means differentially phase shift keying, DEPSK means differentially encoded phase shift keying. Whereas here in the baseband transmission, we are again dividing into two types, which are pulse analog and pulse digital. Here the pulse analog is again classified into three. They are PAM, PWM, PPM. Pulse amplitude modulation, pulse width modulation, pulse position modulation. Next, whereas pulse digital modulation, PCM, DPCM, DM and ADM means pulse code modulation, differential pulse code modulation, delta modulation, adaptive delta modulation. All the 4 types are termed as source encoders, means these are used to convert the analog signal to digital signal. By improving the technique based on the previous disadvantages, these 4 types are used to convert analog to digital information. Whereas MRS schemes means here in the MRS schemes we use QPSK, 8 PSK, 16 PSK, 16 array PSK and M arrays. Okay, this is the full complete detailed block diagram of communication. In previous classes we can study that analog communication system block, means here the both message signal and carrier will be analog in nature. So this is the block diagram for analog communication system, which consists of information source. Input transducer means a microphone, a transmitter means here modulation includes, and a channel, next receiver, and output transducer means at the receiver side. This is the detailed block which consists of source, modulator, transmitter, channel, receiver, demodulator, and destination. It is the analog communication system block diagram in detail. Means between the source and the transmitter, the modulation takes place. What do you mean by modulation? As we know that it is the process by which some characteristics of the carrier are varied in accordance with the message signal or modulating signal. The main purpose of this is to transmit message over longer distances, to transmit signals from various sources simultaneously over a common channel. Now let us see what are the blocks present in the digital communication system. These are the blocks which present in the digital communication system. Here we include information source, which will be analog or digital. But here we are using digital communication system. Means first it will be in analog in nature. Next we are using encoder block. Next digital modulation as we studied in previous slides. Next it will go to the channel. Next from the channel it is received at the receiver. Again the reverse process will happen. Here the digital demodulation, channel decoding, source decoding, and info sync, which is nothing but our user destination message signal. These are the complete blocks. Now we will see individual block separately. First of all, we have transmitter. Here in the transmitter, first of all, we have information source. The information source may be analog or digital type. Next, this analog or digital information is passed to next block, which is source encoder. The main objective is represent the source signal as effectively as possible with a few bits as possible. Means here it will convert the analog information to digital information. So here we use the A to D conversion techniques, which are source encoder techniques, which is the first unit we will see later onwards. Next, channel encoder. Channel encoder adds some extra bits to the digital information. These bits doesn't contain any information. These are used at the receiver for error detection and correction. While signal is transmitted, there is a chance of getting noise accumulation through channel. Hence, errors are introduced in the binary sequence received. So, this is the reason why at the receiver we use channel coding, and it provides a reliability. Digital modulator. So here we see that at the receiver and not at the transmitter. Means at the transmitter we are using the coding. Digital modulator. The main objective is to send the original message signal by using digital modulation techniques for longer distances. Okay. So whether it will be binary modulation or M array modulation. Here we use digital modulation techniques which consists of continuous high frequency sinusoidal wave as a carrier signal. Next, here we use different techniques like ASK, FSK as we see in the tree diagram or classification of communication. Next, receiver. At the receiver we have digital demodulator. Means it is used to reconstruct the transmitted data symbols or M array from channels corrupted receiver signals. Next, channel decoder. The main function of channel decoder is to detach the extra bits which are added at the transmitter side. Okay. Next, source decoder. Source decoder, again it reconstructs the original signal from output of the channel decoder. Next, communication channel. The connection between the transmitter and receiver is established through communication channel. Communication may take place through wirelines or wireless or optical channels. The other media such as optical discs, magnetic tapes, and discs, etc. may also be used for communication channel to carry the data. However, there may be some problems through communication channel, like signal attenuation means the attenuation of the signal or blockage of the signal, amplitude and phase distortions. There is a chance of additive noise interference and multipath distortions. Next, we will see the advantages and disadvantages of digital communication. The foremost advantage is here we use digital integrated circuits. The main function of the digital integrated circuits is to handle discrete signals such as binary values in which true or false logical operations are used. Basic Boolean functions such as and, or, not are essential in building functionality of modern digital systems. So, how it is linked to digital communication system means digital communication system is simpler and cheaper when compared to analog communication system because of this advancement in IC technology. So nowadays whatever we are using like laptops or mobiles or any equipment, these are integrated with ICs. So the ICs require the data in digital format. So here in digital format when we are transmitting the data, so it requires most adaptiveness of communication system, which is a digital communication system. Means simply we are adapting to the digital communication system in this way by using digital integrated circuits. The next advantage is in digital communication, speech or video and any other data may be merged and transmitted over a communication channel, which is a common channel using a multiplexing. Here we can see different types of channels which can carry the information as shown in the figure. The next advantage is mostly it is most secured transmission because using data encryption only permitted receivers may be allowed to detect the transmitted data. So it is mainly useful in military applications to transmit the data. So while transmitting, the data will be shown, but at the communication channel, if any hackers or any bad guys transfer or track the information, they cannot retrieve the data because at the transmitter side we are using different encoding techniques. So due to this, it will be known to the bad guy what type of technique he is using. So without knowing that, he cannot retrieve the data in the middle of communication channel. Only receiver can know what type of technique he used. Then only he can retrieve the data at the receiver. The next advantage is transmission is digital in nature, as we know that. So channel encoding is used. Hence, noise doesn't accumulate from repeater to repeater in long distances. So we are using repeaters to retrieve the original signal again in the communication channel to reach the signal exactly what is transmitted and at the receiver to reach it. The next advantage is since transmitted signal is digital in nature, as we know that, therefore large amount of noise interference may be tolerable. Means it can tolerate most of the noise which is accumulated in the system can be tolerated, means it can be avoided. The noise can be avoided and original information will be get out from the equipment. The next advantage is, as we know, as previously said, we are using channel encoding techniques or channel coding techniques. So errors may occur in the channel, but they are again detected and corrected at the receiver. As we know that there are different techniques like LRC, VRC, longitudinal redundancy check, vertical redundancy check, or Hamming codes, or something techniques we use so that it can be retrieved data at the receiver. The next and foremost advantage is that digital communication is adaptive to many branches. For example, here I mentioned three of the branches which are adaptive to digital communication. The first one is digital signal processing, and second one is digital image processing. Third one is data compression techniques. But how many advantages are there? But there will be at least certain disadvantages. The first and foremost disadvantage is due to analog to digital conversion, the data rate may become high. What do you mean by data rate? The data rate is nothing but the transmission speed or the number of bits per second transfer. Therefore, transmission bandwidth required more for digital communication. As the number of bits increases to transfer, the bandwidth also increases, which results in which results in bandwidth increment. Thank you. So this is the introduction about the digital communication. Thanks for watching.